So out of n objects, that's how we always call this total, turns out. We have selected R, many of them. Then what you get is a way to permute these R elements around. So what you do is you take n factorial and you divide by the difference of n minus R. And the idea of this formula, we also saw that we actually need to take these n objects and we need to go with n minus 1, n minus 2, and stop at some place, which is called as n minus R, something like that. But what we are actually doing is we're using the formula with factorials, because when you are trying to, say, multiply numbers, like, for example, they do here, 7 by 6 by 5, and stop at that stage, so they don't continue 4, 3, 2, 1. So turns out we have factorial formula that could be utilized. So if you get 7 factorial with the 765 that you need and extra 4, 3, 2, 1 that we don't need, so we cancel this with our denominator. But it's a nice short way to write things down. So technically you just go n minus 1, n minus 2, all the way to some point and stop. So you don't go all the way to 1. But since factorial is very compact, that's why we're using it. So technically we don't have to use it. We could always do this in 2, but it is helpful. It is helpful, and I want to do the problem for you to see how we utilized this formula last time. For example, exercise like 45 that says arranging books on a shelf. So if you have 5 different books, and if you want to see how many ways you can possibly put them on a shelf and how many different orders you have, the answer will be out of 5, you choose all of them, all 5, and see how many ways you permute them around. So permutations, they always select out of n so many items. So you could say it's permutations out of 5 to choose all 5, and this is that possible answer. And this could be also treated as if I used 5 factorial, because if I have 5 positions to put these 5 items into, then I have 5 selections for the first one, right? And then 1 less will be left for the second, because you already put any of these 5 books in the first spot. So now I have to fill the second spot, and I have 1 less because 1 is already taken. So 4 remaining books, I can select any one of them, and means times, go down 3 and 2 and 1, and that's actually nothing else but 5 factorial, right? Or you could actually multiply these numbers or use a calculator and get the answer. So, way to arrange those 5 books. How about one more here? Like, for example, 37, another nice permutational exercise. In this problem, they have, again, 5 different elements, and they want to just choose 3 out of those. So the key idea is when you select 3 and see how many ways you can arrange them. So 3-letter codes that are different. So I take permutations, how many ways I can arrange those letters, those 3 letters when I select them out of 5. And you can multiply 5 by 4 by 3, right? Because that's 3 positions. Or what you could do is get a calculator. I wanted to show you today that there is a scientific calculator. Remember Desmos? That's the one I always use. So it's a free calculator called Desmos. Now, there is a way to find permutations, but you need to go to the functions menu. So you need to click here, functions. And in the last row, you see factorial, and here's number of permutations. So what I need is put in the parentheses numbers. So I need to go back to the main menu, see, functions menu, main menu. So I need to put 5, comma, 3, and then parentheses. And it give me the answer, which is 60, which is going to be a product of 5 for the first position, right? I have 5 elements, and then 4 for the second position, and then 1 less 3 for the next position. And then we stop because we just choose 3 from 5. And notice it's going to be 20 times 3, which is indeed 60 that calculator gave us. So you can use a calculator. You don't have to always multiply these numbers because it'll take you a while because the numbers get pretty large. Let's say if you decided out of, say, 35 people in class to choose 3, well, right away you can see how many ways you could arrange these 3 persons selected. So you could play with this permutations calculator for fun. The idea is otherwise you're going to have to multiply 35 by 34 by 33, and you will get the same exact answer anyways. So it is really up to you. Some people like intuitive way to do it by hand, but I recommend you to do this also using a calculator, because you will see this in the chapter 12. That's where we're little by little coming to. In fact, in the chapter 12, they're not using permutations. What they're using is the other formula here, which is called combinations. Combinations formula, if you compare it with what we have here for permutations, has one little extra, r factorial. So there is a formula very similar to permutations. In fact, it starts out the same, but then it has a little bit more in its denominator. The reason is we don't care about the ordering of elements. So when we select these same R elements from total, which is n, we don't really care how we're gonna order them. What does that mean? Well, for example, you have purchased some fruits and you put them in the basket. So you don't really care in which order you have the largest tomato, the smallest tomato. You don't arrange them. You just put them all in one spot, and that way you kill all of the arrangements. For example, if you have here selected 3, oh, let's say 45, that'd be better. If you select all 5 out of 5, then you see how many arrangements you have. There are 5 factorial arrangements, right? And you just took all 5 out of 5, so there is only one way to do this. So this 5 factorial could be killed by placing it in denominator. In other words, if I try to get permutations here, I'm gonna have to put 5 factorial according to the formula. Where is the formula? Well, on the upper left corner, right? Formula, permutations from 5, choose 5. And then I have to divide this by 5 minus 5 factorial. And say, what is 5 minus 5? That's a 0. We don't divide by 0. Well, turns out that 0 factorial is 1. 0 factorial is 1. Are you sure, Alex? It's not 0. How do we get factorial? We started, say, 5 factorial. 5, and then 4, 3, 2, 1. There is no 0. Well, this is definition. Definition means we have to trust it. Well, for our classes definition, turns out in the later classes, if you do more math, you will see that factorial could be also taken of fractional. So various decimals you can do factorial. There is a special functions that actually boils down to multiplying 5, 4, 3, 2, 1 for 5 factorial. But if you use the same function for decimals, it's not that. It's totally different. So this is like a subcase. If you take the whole numbers, then you use this formula, but there is a general case, turns out. And you can actually check this with a calculator, so you can try to find this factorial thing like a 0. Remember, I need to go to functions, right? To get factorial, put 0 factorial, and it tells you that this is 1. Because otherwise this formula wouldn't make sense, because if it's a 0, then we don't divide by 0, so it's always 1. So is that something new? I didn't know I could divide by 0. Well, it's not 0, it's 0 factorial. It's something totally different. See? So what about if I used combinations? In other words, in exercise 45, we did care about the order. Let me go there to double check what they were asking. In 45, they say arranging books. So you put them on a shelf, you don't put them in the box. So you just arrange. You could put calculus in the first place, or you could put pre-calculus. See, that'd be the different arrangement if you switch books around. But what if you just put them in the box? Say you're moving, so you don't care in which order you have those books. As long as you have all your 5 math books in the box, that's good. So how many ways can I do this? Well, it turns out only one way, because you don't care about the ordering of these books. So what you do is you kill all of these arrangements, and we have 5 factorial of them. So you need to put another 5 factorial on the bottom, and this way you cancel these factorials, and at the end you get 1 on the top, because when everything is gone, you get 1, and 0 factorial, which is 1 on the bottom. So if you decide to go combinations, how many ways you can put 5 books in the box? Well, just put them in the box one way. They all be there, 5, comma 5, and this is equal to 1. And of course, I can double check this using the calculator. So I can actually go ahead and select get my favorite calculator. And again, I need to go to the functions, right? Functions, not main, but functions, where the combinations are, and it is here. So now I go back to main, and I put 5, and then comma, and then another 5 in parentheses. And you see that indeed it is equal to number 1. So point is, yes, formulas work, and yes, you can do the same procedures, people say intuitively, which means without the formula. Intuitive way is nicer, because you feel that you are doing it right. But turns out all you need to care about to use formula, if you care about order, then you use permutations because you permute. Ordering means permute, switch those elements around and get different arrangement. So if you switch books, right, like put trigonometry first instead of calculus, so you switch, you get different order. But if you don't care about order, so you just see how many books you actually have and don't order them, then it's combinations. And that's the key idea, which formula to use. If you care about ordering, that's permutations. Or if you do problem number 41, if you're trying to select committee and you treat each person in that committee equally, so you don't really order, you don't say you're the first, you're the most important, you're the last, you're not important at all. So you're not doing that. Everybody is equal. So if you have a pool of 7 students, and out of 7, you choose here 4. So you choose from 7, 4. And do you care about order? And Alice, how do I know? Nobody told me anything, but just choose 4 out of 7. Well, if nobody told you, then you don't care about order. If they gave you that fact, then you do care. But if nobody told you, it means there is no order important. So right away you get a combinations. And of course, I don't want to use this formula here. I know some people prefer to do that, but it's a little bit tedious to mess with all these factorials. All I do is I just put combinations. And then in the parentheses, I need to go back to main, 7, comma, 4, and it's 35. So there are 35 ways to select 4 student committees out of 7 students. And that way you don't really care about order. So please notice if you start to actually think about the intuitive way here, so I already done with the exercise. This is the answer. But just to show you that if you stay, okay, on the first place, I could put any of 7. On the second place, but see, there is no first, second, and third and fourth places. There is only a group of 4 people who don't arrange. So if you start arranging, say, okay, first place is 7 choices, next place 1 less 6, and then 5, and then 4. Of course, it's going to be much bigger result. Of course, it's going to be, what is this? Like 7 times 6 is 42, and 5 times 4 is 20. So 42 times 20 is actually 42 times 2 is 84, right? So it's like 840. That's way more. But that's when you care about the order. So when you select your 4 people, you start to permute them. So how to stop with this? You want to kill this arrangements of 4 people, which is 4 factorial, because you can put on the first position any of these, on the second, next 3, then 2, then 1, right? So if I cancel this 4 factorial, which is going to be 4 times 3 times 2, right? 4 factorial, 4 times 3 times 2. Then I should get 35. And I better get 35. So you can cancel, you can see that 4 should disappear here. And then 6 is 3 times 2 should disappear. So all you left with is 35, right? When you divide 840 by 24, you get 35. Or you can use a calculator, just trying to show you that these formulas do work, and it doesn't really matter if you do this intuitively or if you use the formula. But of course, this intuitive approach is a little bit too much. I think if you can use the formula, then everything is nice and straightforward. So I'll do one more exercise with combinations and I guess let you go. And next time then we will return back to chapter that we were working on. So we can actually see that so-called binomial theorem, which is sometimes useful when you deal with various powers of sums or differences. We'll see that next time. Just get one more exercise for you and let you go. This combinations, permutations is quite something. And if you like this, well, think about taking a statistics class. That's where we use them. And also in the, I don't remember MGF, which one of them, there are two of them, but now they changed their numbers. So I don't remember, it's some new numeration for those. So we also use combinations and permutations, of course, heavily in those classes. So if you like this counting, it's called counting principles, well, then those might be classes for you, especially statistics is very, very popular. So I would recommend that you can always utilize it as elective course, because it's always impressive if you take elective course in mathematics, then it's definitely something that actually always being accepted for transfer. So anyways, let me try another exercise here and see what happens. So how about if I try exercise? So we had committees of students, maybe committees of professors in the department that has 8 of them, exercise 42. So we choose out of 8 people, 3. A little bit lighter colors, so you better see this. So out of 8, we select 3. The key question is, do I order these 3 people or I just keep them as a committee? And they say just a committee, so we don't arrange. Say, how could you possibly arrange them? Well, if you say, well, that's a chair of the committee, that's a vice chair, and that's a secretary. So then it definitely be ordering. So once I select 3 people, they start to be arranged. First could be the chair, or second could be the chair, right? So that's a little extra possibilities. But here we don't care for that. So we use combinations. Order is not important. So out of 8, I select 3, and I just go ahead and use a calculator. Because every time to do this cancellation of fractions, I think is a little bit too much. That's what we actually used all days, because when we had old school professors, they hated calculators, technology, and everything. So that's why they would always do this by hand. Well, I here show you that, so I think it's good to know the intuition was behind, but I think you should use calculator because you will kill lots of time doing the same thing, all this arithmetic, factor and cancel. It's a little bit too much. So take functions, right? See, that's an awesome calculator. It's free. I highly recommend you to use it, especially if you're going to take more classes like statistics, because it enables you enter all of these numbers in a calculator and see them. And if you want to change them, you can always highlight that number and change it. And that's definitely helpful. So anyways, 56 is the answer. And I will let you enjoy the rest of beautiful Wednesday. And Friday, we're going to be working on the last section of previous chapter. And that section uses combinations. I just want to show you. So that's the reason why I went and skipped that first section with sets. That's, I guess, not being used. It's kind of separate story, but the last section here deals with this combinations, but they write them differently. So they write them like that in the parentheses. Turns out sometimes they write combinations in the parentheses. Sometimes they write combinations without. So they put like 0 choose out of 4, 1 choose out of 4, 2 choose out of 4, 3 choose out of 4, and people look at that and just panic, say, what is that? I mean, that's combinations. So I think that you should know what combinations are before you start to use those combinations. Otherwise, it's kind of confusing, right? So that's what they have here. So combinations. And they say using Wolf symbol like that, and they don't even use word combinations. I think that's a missing part of the textbook, because it's actually combinations, but they don't use the word combinations, and they actually talk about them in the next chapter. So we'll see all that next time. So next time we're gonna definitely enjoy combinations and more depth, and we'll see why they actually have these symbol combinations in here. So we're gonna continue on Friday, and then next week, Monday, we'll see what we're gonna do Monday, because Wednesday, I'll be already starting to prepare you for the final exam, right? So you were asking when the finals, 2 weeks from, it's actually less than 2 weeks already, we'll have a final. And I'm still waiting for some work from some students in this class, because some students still owe me homework for the first part of class, and well, maybe they're fine with lower grade. So if they don't turn in homework for the second part of the class, which is what we're working on now, they're going to lose more points. So the grade will go lower. So I just want to remind people that I will accept late homework. So please send me whatever you've done. Why not? Don't be shy. You'll get more points. Just make picture and send me by email. You can send me several emails. That's fine. If you have a lot of pictures to make, again, make a picture and send me one email, another picture. You can send me 100 emails. That's fine. Just send it to my school email address. Okay. So that's for the,
Professor,
yes.
when is part 2 of the homework due?
On the day of final, it'd be ideal, because we're gonna, let me show you the rest of the semester. So calendar where this semester, which is running already by, says that we are done here. 25th, I must submit grades. On 25th is the last, very, very last day when you can send me whatever you want to send. That's why I make a due day on 22, because this way I know some students like to always miss the deadline, so they will send it to me on 23, 24. So you still have a few days after. I will accept it, but once I put grades in the system, I no longer have access to it. They say, what if you don't put? What if you wait? Well, if I don't put grades in the system, they will give me a hard time. They will say, Alex, where are the grades? You must put the grades. So they will be calling me. So I have to put grades. I don't have a choice. So on 25th, late at night, I put grades. After that, that's it. Grades become property of the college. I no longer have access to them. I cannot change them. And if you send me late work, there's nothing I can do with it. So that's for people that love to submit work late. I always get people that send me work sometime in August. And I'm very sorry, because so much easier that you send it to me before the deadline, because after the deadline, well, you can try to contact our dean and explain her why you are turning in late homework and, because it has nothing to do with me, I don't have access to the grades. If Dean decides to change your grade, I don't mind, I don't really care, but, I don't think she will. So, do this on time, that's the key, okay? If you come up with the very sophisticated excuse for that and bring some documents that prove it, well, they might extend it, give you incomplete and do all this extension, so you will go through so much trouble because of that. It is possible, I'm saying it's nothing is impossible, but just for you to realize it's so much easier, just send it to Alex, whatever you have, I'll give you full credit, I'll get so happy, I'll give you full credit for all the work you've done, and that's it. You will be done and you will have August off instead of having August headache. So please think about it. So 25 will be the very last day, but I set 22nd for the deadline, the final exam. I will be emailing on 22nd, probably earlier. So we're going to discuss that previous week, which is going to be next week for us, and the 17th, then 19th. We'll discuss final just like I did with the midterm. And by the way, I uploaded all of the lectures we had up to this week on the YouTube channel. So you could just look at those lectures. The link is in the syllabus. Some people even subscribed it, so that was much easier. Excuse me. I think that's much easier for you to get there. Do same problems. Just copy the same problems. If you didn't do homework yet, copy the same problems. And email it to me, so you will get a full credit, because homework worth what? 20% of the grade? So instead of A, you will get a B simply because you never sent me home. I think it's not fair. In fact, I think it's a good that I give you ability to raise your grade by 1 if you turn in the homework. So I'm just trying to convince those students that did not submit homework yet to do that. You still have plenty of time. So do it over the weekend if you want to. Okay. So I will raise your grade. So anyways, I think enough with that. I'm gonna stop for today. Any other questions, please ask.
Professor, when is the final again?
I'm sorry.
When are we having the final exam?
We try to make it louder. When is the final?
Yes, when are we having the final exam?
22 of July.
Okay.
Okay, good.
All right. Thank you, Professor.
Thank
Very
you.
kind.
Bye-bye. Have a
Bye.
good.
I'll go with Wednesday.
Thank you, Professor. Have a great day.
Bye-bye.